Hey everybody, today we're going to be going over the second section of Unit 2, which is entitled Our Lines Parallel. And this is really going to be more of an extension of what we learned in section 2.1, because basically we're just taking these four relationships and talking about how you can use these to prove lines parallel, okay? So let's go through this fairly quickly because this doesn't really take a whole lot of time. So corresponding angles. So what we're saying is, I should probably start from here. Two lines are intersected by a transversal, and any one of these things are true, then the lines need to be parallel. So these first three are really easy to remember. Okay, it's all congruent. So if corresponding angles are congruent, or if alternate interior angles are congruent, or if alternate exterior angles are congruent, and the one that stands out is consecutive interior, which is also known as same side interior. They both mean the same thing. They have to be supplementary for that to be the case. And I'll remind you that supplementary means that they add up to 180 degrees. Okay. Let's do some examples. So, excuse me. Determine if R is parallel to S. Remember that notation, okay? So let's zoom in a little bit more. So determine if R is parallel to S. So what I like to do when I'm going through a problem like this, I like to identify the angle relationship first. Okay, so this is the interior, this is the transversal, this is the exterior. So these are alternate exterior angles because they're on opposite sides of the transversal and they're both on the exterior of this situation here. So we're going to say alternate exterior angles, and I urge you to do the same. Is identify these each time, and it'll actually help you memorize the relationships, okay? So in order for these lines to be parallel, the alternate exterior angles, let's go back here and check, have to be congruent. So these would have to be the same value in order for these to be parallel, which they're not. So this is 65 degrees, this is 63 degrees, so we're going to say not parallel. Okay, let's check this one out. So this is the interior, this is the exterior. These are on the same side of the transversal, so therefore this would be same side interior angles, okay? So, and we'll remember that same side interior or consecutive interior have to be supplementary in order for the lines to be parallel. So let's see if these are supplementary. So let's add them together and see if it adds up to 180 degrees. So 93 plus 87 rather. 3 plus 7 is 10, carry the 1. Yep. So yes, these would be parallel. Okay, let's go ahead and, forgot Mel there, check out the examples in the back here. So, zoom out so you can see this. There's a whole lot going on here. Now, let's read these directions carefully. It says, given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So all I need you to do is, first of all, identify which lines would be parallel, and then say which of these four reasons makes that case for you. So let's go ahead and look at this first one. So measure of angle BCG plus the measure of angle FGC is 180 degrees. Okay, let's identify where that angle is. So BCG, so from B to C to G. So this angle right here. So that angle there, okay, plus FGC. So FGC is this angle here. So these two angles, if they add up to 180, so in other words, are they supplementary? So this looks like same side interior to me. That's exactly what it is. And if it makes your life easier, you can actually ignore that other line. And I find that to be easier. So I'm gonna write down the relationship. I know it doesn't ask us to do that, but I find it helpful for me when I'm trying to remember these relationships here. Same side interior. Which lines would be parallel? Well, it'd have to be these two lines, right? And you can name these a few different ways. You just have to use 2 points that are on the line. So I'm going to use KD. So KD is parallel to, and then it'd be this other line. So this would be EG. And again, you could use any 2 points that are on these lines. You don't have to use the same two I'm using. And because the same side interior, okay, and that's it. Yeah, so identify the relationship and then say if they're parallel or not. So number 2, CBF. So CBF is this one right here. I'll use a different color for that one. Let's use a red one for that one. So CBF is right here. Okay, so CBF is going to be this angle here, and then GFH is this angle here. So these two angles are actually going to be corresponding, and in order for those lines to be parallel, the corresponding angles would have to be congruent, which they are. So we're going to say these lines are parallel, so KD is parallel to EG. Okay. All right. Why don't you go ahead and try these on your own? All right. We'll do a few of these down here. We'll do like 2 of these. So find X so that L is parallel to M. The notation here kind of gets screwed up, so I'm going to rewrite that. L is parallel to M. So let's identify the angle relationship. So these would be corresponding, right? From here to here. It's corresponding. And we know in order for the lines to be parallel, the corresponding angles would need to be congruent. So we're going to set these equal to each other and solve for x. So we're going to say 3x plus 6 equals 4x minus 6. And we're going to go ahead and solve for x. So we're going to subtract 3x from both sides. And we're going to get 6 equals x minus 6. And then we're going to add 6 to both sides. And that's going to be x equals 12. Let's do one more. Let's do number 10, actually. So let's zoom in a little bit better here. So these two angles here would be same side interior. And we know in order for the lines to be parallel, the same side interior angles would have to be supplementary. And I'll remind you, supplementary means they have to add up to 180 degrees. So we're going to set that up algebraically. We're going to say 3x plus 10 plus 5x plus 18 equals 180. And we're going to go ahead and solve for x here. So let me give us some room here. There we go. So 3x and 5x, we're going to combine like terms. That's going to give us 8x. And then we're going to combine 10 and 18. And that'll give us 28. And now we just have a two-step equation to solve for x. So let's subtract 28 from both sides. Excuse me. 8x equals 157, it looks like. No, not 57, I'm talking 57. So I can't do math in my head today. 52, I'm sorry, 152, yeah. Is my math right? Yeah, my math's right. Okay, I had to think about that. Divide by our coefficient, which is 8. And x will be equal to, let's see, 1, so 19, it looks like. X is equal to 19. Yeah, that works. All right, so those are 2 examples to make. You can try the other 4 on your own. And that's basically how you're going to go ahead and solve this. So the homework tonight is going to be mostly problems like this, okay, where you have to identify the relationship and then solve for x. All right, so hopefully that was helpful, and let me know if you have any questions. Thanks, guys.